Okay, moving on to Chapter 3, Descriptive Statistics. So we're going to look at measures of center first for ungrouped data. And for this video segment, we're going to look at the mean, median, and mode and how to calculate those. So have your calculators ready for those calculations. So starting with first the arithmetic mean, or simply the mean. And the mean is the average of a group of numbers, and it is applicable only to interval and ratio type data. And I'm sure everyone knows how to calculate an average grade, or an average temperature. But let's take a look at the notation. So x1, let's say we have a data value equal to 6, and our second data value is 7, and say we have a third data value equal to 8. So we can see that the average would be 7. But for notation, we want to get used to using this capital sigma from the Greek alphabet, and it means to sum or to add. And it's like a shortcut or a shorthand for this. So sum of all the x's, the sum is equal to 21. And we know to get the average, we want to divide by the total. In this case, we would divide by 3 because we have 3 in our sample, and that equals 7. And so you want to get used to the notation sigma, and we use it throughout the course. All right, so the population mean is mu that we've discussed before, and it is the sum of the x's divided by capital N, and capital N denotes the size of the population. The sample mean, we use x bar, and that's equal to the sum, and then this time divide by lowercase n, and that denotes the size of the sample. So we can distinguish between the size of the population to the size of the sample by using the capital and lowercase n's. All right, so here's an example I want you to try. We have a set of class grades, and you can check and see if you can calculate the sample average grade, and then check your solutions in the Chapter 3 solution slides below this video. All right, so give that a try, see if you get the correct answer. The impact of extreme values on the mean, if we have a very large number in our data set or a very small number, those numbers will significantly distort the mean. So let's say, for example, here we had, instead of the value 42 or even 38, if we replaced one of those with 0, that obviously would decrease this sample average value. Likewise, if we change, say, the 66 to 100, then that would significantly increase the average, right? So these extreme values, whether they be large or small, will significantly distort the mean. All right, moving on to the median. The median value is the middle in the ordered array. It's the middle value. So ordered meaning here is smallest to largest. You need to make sure that your data set is in order from smallest to largest to determine the value of the median. If you don't have it in an ordered array, you will not get the correct value. And the median applies for ordinal, interval, and ratio data. And the advantage is it is unaffected by the extremely large and extremely small values like the mean is. And the reason for that is because the median is a position value, and that has a disadvantage. So the median does not take into consideration all of the values in the data set when it's calculated. It's like the mean does. It is instead just the position value, right? So that's the disadvantage. So how do we calculate the median? Well, the first step is to get that ordered array, smallest to largest. Second step, if the array is an odd number of terms, the median is simply the middle number. So let's say we have a tiny data set of 3 values. So x1, x2, and x3. The median in this case would be the value that goes with x2. And remember, these values would be in order from smallest to largest. Okay. Third step, if your array is an even number of terms, then the median is going to be the average of the two middle ones. So let's say we have x2, x3, x4. We cut the data in half. We have 2 below that line, 2 above that line, and the median value is going to be the average of x2 and x3. So you would take x2, add that value to x3, and divide by 2. So you will get the average of those two values, and that will equal the median. So moving on, oh, there's a little formula here. n plus 1 divide by 2. It will give you the location of an ordered array if you want to use that. You don't have to use that formula, but it can be helpful if you have a larger data set. So let's say you have 3 here. So if n equals 3, so n plus 1 divided by 2. If n is 3, you would have 4 divided by 2, which is 2. So the position 2, right, would be the second value in that data set for n equals 3. If n equals 4, you would have 4 plus 1 divided by 2. That would be 5 divided by 2, which would be 2.5, meaning that you would take the average of the second value and the third value to get the middle in between. So you would take the first value and the second value, divide by 2, add those together, divide by 2 to get the median value, which is what we did. All right, so let's try an example with a larger data set. So we have an ordered array. I've already put these in order from smallest to largest. Okay, so you can see that. And what you want to do is count how many is in the ordered array. So we have 17, so an odd number. And so the position, we can use the little formula here, n plus 1 divided by 2, or we can just simply go, okay, if I make sure there's 8 above the value and 8 below the value, so if I take 15, I have 8 values above it and 8 values below it. That must then be the median, capital N. And or you can just use the formula if you want. Right? So that is how you find the middle of the data, the median. If the array is an even number, this time we have even numbers, so there's 16 instead of 17, then you can use the little formula again, or you can just simply go, okay, it's going to be, I'm going to cut the data in half such that I have the same number of values above and below it, and then I'm going to take the average of the two values directly below that line and above it. 14 plus 15 divided by 2 is going to be 14.5, and that will be the value of the median. Okay, the mode, finally the mode we have here is the value in the data set that appears the most frequently, and it applies to all levels of data measurement, nominal, ordinal, interval, and ratio. And if you have one value in the data set that appears the most often, it's unimodal. If there's a tie, then it would be bimodal. And if there's more than 2, then there would be, we would call that multimodal. All right, so let's look at an example. This example here, the data is already arranged in an ordered array, smallest to largest, and from 35 to 48. And we can see that the mode in this case, you want to go through each one to see how many numbers appear the most often. And we can see that 44 appears 1, 2, 3, 4, 5. And no other number in this data set appears more than 5 times. So this would be unimodal, and the mode value would be 44.